This video explains how to simulate an XY table on MELSOFT Gemini by linking imported CAD data with a control program. This video is based on MELSOFT Gemini version 1.50. In this demonstration, an XY table is controlled by a simple motion module and is operated by synchronizing the current value of each axis with the XY table on Gemini. The 3D model used this time has 4 movable parts. The component 1 moves along the x-axis, and component 2 moves along the y-axis, both controlled by the simple motion module. The component 3 moves along the z-axis and is controlled by the on-off signals. The component 4 moves linked to the movement of the component 2 and rotates around the center of the circle. This section explains how to import a 3D model. Click Geometry, and a file selection window will appear. Select the 3D CAD file to be used and click Open. The Import Model panel will appear. If the coordinate system differs between the 3D CAD system used in Gemini, change the up axis setting. For the model for this demonstration, set up axis to -x. Click Import to import the 3D CAD data. This is the end of the explanation of how to import a 3D model. Mechanism setting. This section explains how to extract movable components and set up the mechanism. Configure the settings for the X, Y, and Z axes respectively. First, set the mechanism for components that move along the X-axis. Select the Modeling tab. Hold down the Control key and select the components that move along the x-axis. After selecting the movable components, right-click and select Extract. Extract link. Link_1 is added to component graph. With demo_XYZ table selected in component graph, select Behaviors and add Motion Controller in Motion. In component graph, select Motion Controller, Drivers, and then click Add Joint Driver. Confirm that J1 has been added to drivers. Measure the motion range and set movable range. Select the Modeling tab. Tools. Measure. Select the start and end points of the motion along the x-axis and measure the distance. The maximum movable range is 900 mm. In the Properties panel for J1, enter 0 in minimum limit and 900 in maximum limit. Set the motion direction of the moving part. With link_1 joint selected, click Add Joint and select Add Prismatic Joint. Select Add Prismatic Joint for linear motion and add Revolute Joint for rotational motion. Confirm that Prismatic has been added to joints under link_1. By adding a joint to link_1, Utilize New Motion Controller is automatically selected in the Link Properties panel. The X, Y, and Z axes and the plus and minus directions for the selected prismatic link are shown by the arrows enclosed in red. Red indicates the X-axis, green indicates the Y-axis, and blue indicates the Z-axis. Each arrow direction is plus direction. The default motion direction is plus Z. Change the link_1 motion direction to plus X. In the Properties panel for Prismatic, enter 90 for the coordinate RY. Set value source to From Driver to use the driver value as the current value of the moving part. To control link_1 with the J1 of the motion controller. Set controller to motion controller and driver to J1. Select Interact and drag the link_1 component along the x-axis to confirm that it moves linearly. Select demo_XYZ table, then the Motion Controller tab in the Component Properties panel to check the current value. The component exceeds the movable range. By selecting the Program tab, Limits, stop at Limits, the motion can be limited to within the movable range. Select the Modeling tab. Next, set the mechanism for components that move along the y-axis. In the same way as for the x-axis, select the components that move along the y-axis and click Extract Link. Link_2 is added to component graph. With motion controller, drivers selected, click Add Joint Driver. Confirm that J2 has been added to drivers. Since the motion range is the same as that of Link_1, enter 0 in minimum limit and 900 in maximum limit in the Properties panel for J2. With Link_2, joints selected, click Add Joint and select Add Prismatic Joint. Confirm that Prismatic has been added to joints under Link_2. Change the Link_2 motion direction to +Y. In the Properties panel for Prismatic, enter -90 for the coordinate Rx. To control Link_2 with the J2 of the motion controller, set controller to motion controller and driver to J2. After the setting, move the movable component. Select Interact and drag the Link_2 component along the y-axis to confirm that it moves linearly. The settings up to this point are the same as the previous one. In this state, even if Link_1 is dragged, Link_2 will not follow it. To make Link_2 follow Link_1, drag and drop Link_2 into Link_1 in component graph. Next, set the mechanism for components that move along the z-axis. In the same way as for the x-axis and y-axis, select the components that move along the z-axis and click Extract Link. Link_3 is added to component graph. With motion controller, drivers selected, click Add Joint Driver. Confirm that J3 has been added to drivers. Since the motion range is 100 mm, enter 0 in minimum limit and 100 in maximum limit in the Properties panel for J3. With Link_3, joints selected, click Add Joint and select Add Prismatic Joint. Confirm that Prismatic has been added to joints under Link_3. Change the Link_3 motion direction to -Z. In the Properties panel for Prismatic, enter 180 for the coordinate Rx. Set controller to motion controller and driver to J3. Drag and drop Link_3 into Link_2 in component graph. Finally, set the mechanism for the component in orange that performs the rotational motion. Click Move. If the link setting is configured in the same way as the components previously explained, the component will rotate around the origin of the XY table, so change the center of the rotation. With Link_2 selected, click Creates a new child link for the selected node. Link_4 will be created as the child hierarchy of Link_2 in component graph. With Link_4 selected, select Snap in the Modeling tab, and click on the position to be the center of the rotation of the component. Confirm that the offset value is entered in Offset in the Link Properties panel. Delete the RY value in Offset and change the Link_4 rotation direction. With Link_4, joints selected, click Add Joint and select Add Revolute Joint. Confirm that Revolute has been added to joints under Link_4. Set controller to motion controller. Set driver to J2, which controls Link_2, the component that moves along the y-axis. To link the component to Link_4, select the orange component in the 3D world. Select the highlighted component in the lower area of the component graph panel and drag and drop it into Link_4 while holding down the Shift key. If you drag and drop it without holding down the Shift key, the component moves to the different location while keeping relative coordinates. Use the Shift key to keep absolute coordinates and not change the current position. Select Interact and drag the components to check that the rotational motion is linked to the y-axis direction motion. This is the end of the explanation of extraction of movable components and mechanism settings. Next, configure the motion settings for the movable components for which the mechanism settings have been configured. With the Modeling tab selected, select Prismatic under link_1. In this demonstration, the current values are sent from the Simple Motion module in 0.1 micrometer. As the unit used for Gemini is millimeters, unit conversion is required. In the Properties panel, set value source to from expression to calculate the current value of the moving part. Enter J1 in value expression so it receives the simple motion value. By changing the expression to J1/10,000, the unit can be converted to millimeter. Since minimum limit and maximum limit should be set to the value range of the Simple Motion module, select J1 under Motion Controller, then set 0 in minimum limit and 9 million in maximum limit in the Properties panel. This completes the motion settings for link_1. Configure the settings for link_2 in the same way. Since link_3 operates according to the on-off signals received from the programmable controller, add signals to receive the signals. First, create a signal for Y101 that directs movement from the return side to the exit side. With demo_xyz table selected in component graph, select behaviors and add Boolean in signal. Boolean signal is added to behaviors in component graph. To distinguish it from other behaviors, change the name in the Properties panel to Y101 to match the corresponding device name on the programmable controller side. Next, create a signal for Y102 that directs movement from the exit side to the return side. In the same way, add Boolean in signal to behaviors in demo_xyz table and change name to Y102. Then add properties to send the current value of link_3 from Gemini to the programmable controller. First, add a property for X101 which indicates that the current value is on the exit side. With demo_xyz table selected in component graph, select Properties, Boolean. Boolean_1 is added to properties in component graph. To distinguish it from other properties, change name to X101. Next, add a property for X102 which indicates that the current value is on the return side. In the same way, add Boolean to properties in demo_xyz table and change name to X102. Finally, configure the settings to operate link_3 according to the on-off signals from the programmable controller. Python script is used for this setting. With link_3 selected, select Behaviors, Miscellaneous, Python script. A programming window will be displayed. You can select the Python version from a drop-down menu. Select Python 3 here. This time, paste the completed program. Copy the program from the text file provided and paste it on the programming window using the Ctrl+A and Ctrl+V shortcut keys. Variables are defined here. The operation is written in while true as an if statement to repeat the process. First, if Y101, which directs movement toward the exit side, is true, set X102, which indicates that the current value is on the return side, to false. Execute the Add Independent Target command to set the motion target on the motion controller. Driver index indicates the index number of the link to move. Target value 1 indicates the target position on the exit side. Execute the Move Independent command to start motion on the motion controller. The await motion.wait unit targets reached command waits and does not proceed to the next command until the motion controller completes its motion. If motion completes, set X101, which indicates that the current value is on the exit side, to true. Next, if Y102, which directs movement toward the return side, is true, set X101, which indicates that the current value was on the exit side, to false. Move link_3 back to 0 and set X102, which indicates that the current value is on the return side, to true. After writing, click Compile and close the programming window. This is the end of the explanation of motion settings. Next, configure sensor settings. Select the Modeling tab and select the sensor model. Right-click and select Extract. Extract component and extract a sensor component. To use the sensor, add a frame to specify the detection position, the sensor body, and a Boolean signal to store the sensor's on-off signals. With the extracted component selected, select Features. Frame. Frame is created at the origin of the sensor component. Drag it to the sensor's detection position. Select Behaviors and click Raycast in Sensors. Raycast sensor will be added to component graph. In the same way, select Behaviors and click Boolean in Signal. Boolean signal will be added to component graph. Change name to X100 in the Properties panel. Select Raycast sensor in component graph and set maximum range and detection threshold to 100 in the Properties panel. Set bool signal to X100 and frame to frame added previously. This is the end of the explanation of sensor settings. This section explains how to connect Gemini and GX Simulator 3. First, start GX Simulator 3. Open the GXWorks 3 file and select Debug. Simulation. System Simulation. Start System Simulation. Select Add System, check the project name, and then select OK. Select the checkbox of RD77MS2 Simple Motion Module and click Start. Write a program to the started GX Simulator 3. On the GXWorks 3 screen, select Debug. Simulation. System Simulation. Connect Simulation. The Specify Simulation Connection Destination window is displayed. Make sure R16 CPU is selected and click Connect. Select the Online tab. Write to PLC, and Online Data Operation window is displayed. Click Parameter plus Program, select the checkbox of Simple Motion and click Execute. During the process, a confirmation message is displayed. Click Yes. When writing is complete, click OK and close the Online Data Operation window. Return to the System 1 window and click Reset. When Ready turns on, select Run. Next, configure the communication settings with GX Simulator 3 on the Gemini side. Select the Connectivity tab. Select Mitsubishi Electric FA in Connectivity Configuration, then right-click and select Add Server. The Edit Connection panel appears. Set PC side interface to GX Simulator 3 and CPU type to R16. Set the type and range of devices communicating with Gemini in Start Device, Points Settings. This time, set 3X devices and 3Y devices that control link_3, 1 coordinate for the current value of link_1, and 1 coordinate for the current value of link_2. First, set the following start device, points combinations, X103, Y103, D1001, and D2001. For D1000 and D2000, set data type to DWORD. After completing the setting, select Test Connection to check whether the connection succeeds. After confirming the connection, select Apply. Click on the icon on the right of Server in Connectivity Configuration. Gemini will start communicating with GX Simulator 3. After the connection to GX Simulator 3 is established, perform pairing of the variables on Gemini with the devices on GX Simulator 3. First, set signals to be sent from Gemini to GX Simulator 3. Right-click Simulation to Server and select Add Variables. The variables on Gemini will be displayed on the left and the devices on GX Simulator 3 on the right. Select X100 on the Gemini side and X100 on the GX Simulator 3 side, and click Pair Selected. In the same way, perform pairing for X101 and X102. Next, set signals to be sent from GX Simulator 3 to Gemini. Right-click Server to Simulation and select Add Variables. In the same way as explained previously, perform pairing for Y101 and Y102 respectively. Select Behavior Properties in Include to display behaviors. Pair J1 axis in Motion Controller in Behaviors with D1000 and J2 axis with D2000. This completes the connection settings. Run the simulation. First, start the Gemini simulation. Next, turn on OPR start of M300 in GX Simulator 3. After OPR all completed of M406 turns on, turn off M300. When M101 is turned on, the automatic circuit starts running. Confirm that the values of D1000 and D2000 will change. Return to Gemini screen. In the Connected Variables panel in the lower of screen, values for Gemini are displayed on the left and the values for GX Simulator 3 on the right. You can check that the components move according to the current value received from the simulator. As for the X100 of the sensor, you can check that detection of contact with the frame is output to the simulator. This concludes the explanation of how to perform a machine simulation using MELSOFT Gemini.